Hey, so there's been a lot of interest in Webpack 5's module federation, and also a lot of questions that have come up from it. Uh, I haven't really gone through how the plugin is put together or how it actually works. Most of the examples that I've put out there pretty much just use module federation plugin. But under the hood, there's actually a lot more flexibility and capabilities to stitch together a federated app. Module Federation plugin is really just the kind of convenience layer that we put in place, but it doesn't actually do anything. We wrote larger plugins underneath it, and that's actually what's powering the whole federation mechanism. So today I thought, why don't we just actually go through the source code of what makes and powers module federation inside of Webpack 5. So this is going to be a little bit of a deep dive, but I think it will be quite informative, and it'll also show off some of the things that I don't really capture in documentation or examples, because I'm mostly just demoing use cases based on my own use cases, and there's a little bit of a lacking in the documentation of it right now, so hopefully this will provide a real look into how everything comes together and actually what you can do with it, or just how it works in general. So with that said, let's just start off inside of the Webpack source code. So I go into lib, container, and we're just going to look at the module federation plugin that I've mostly been speaking about up to this point. You'll notice it's actually really small. There's really nothing that fancy about it. It's purely there for convenience. So what it actually does is really just pull in two plugins underneath it that we wrote, which is container plugin and the container reference plugin. So the reason module federation plugin exists is really for convenience in the case of what I've been calling bidirectional hosts. It's the concept that you don't have a build that's kind of the parent build, but you have a bunch of bundles that can either act as a host or can be consumed by a different host. If you were going to have something like, let's say, an app shell, and nothing's ever going to consume that app shell, it's only consuming, then you don't actually need the module federation plugin. You only need one half of it. The same thing would be said for, say, libraries that you would put out, or things where their intent is only to be consumed. They're never going to be the consumer, and you would never really hit that micro front end or that piece of code directly. It would always be consumed through some other system. So you'll see over here we've got the container plugin, and then down here, of course, we have the container reference plugin. So container plugin is used for remotes. So this is what a remote would have. And container reference plugin is what powers the hosts. So inside of container plugin, what we pretty much do is, we pass it in a name, we inherit or pass in library configurations, and we give it the output file of remote entry, container.js, whatever you want to call it. Then, of course, we actually have the exposes here, which lets us expose specific files and key them under a different name, or just key them under the same name, so that they can be consumed by other applications. Then the last thing we have is this thing we call overridables. And for translation, that is shared. So in module federation plugin, we just call it shared, but it's actually overridables for the remote, and then for the host, it's overrides. So now let's go and look at the container reference plugin, which is what a host would have. And the host only expects the remote type, so what library was used here, and it expects the list of remotes. So the reason we have this list of remotes is so that we can kind of whitelist something that looks like this. If I had, app2 / something. So that right there is what the host cares about, and that's what remotes is doing. So when Webpack starts bundling this application, so when we import something like this, it doesn't error out saying that, no module found. What it'll end up doing is resolving app2 because it knows that it's a remote, and it will create something that's kind of called a remote module or remote dependency. And then, of course, the last thing that we do is we would specify the overrides, which if you're using Module Federation plugin, we just share them between it. But that pretty much means what is the host going to override from the remote. Why this pattern is actually really handy is it allows us to build more sophisticated top-level plugins. So I've kind of mentioned that there's ways to do versioning, and I've showed some code around that, and that's mostly just sitting as like a hydration function that hydrates either the override section or hydrates the remotes part of a federated app. And that really is helpful because I could come up with something like automatic vendor federation plugin. And all we would really be doing is taking module federation plugin and we would replace it with something that has pretty much just more functions that run ahead of time, or something that you pass in a different set of options for your shared or exposes, and it will pretty much generate a list of key values or an array of whatever you're trying to share. We don't have to actually go through and do a whole lot of rewrites deeper down in the app, because we would really just be instrumenting this again and passing it some kind of hydration layer that we would create up here. So that makes it really easy for us to extend this without a whole lot of work. So now that you kind of see what Module Federation plugin is actually consisted of, let's dive a little bit deeper into it. And before we dive in, I think it's important to call out that the Module Federation system is really built up of 3 new plugins that we wrote. And those 3 core plugins really power the whole ecosystem. We've got the container plugin, we have the container reference plugin, and then we have something called the overridables plugin. And that's how we are able to kind of stitch everything together. That's how all of this works, and those are the kind of 3 main things that are happening underneath Module Federation plugin. So let's jump into the container plugin, and we'll start there. Container plugin, again, is a remote. A remote would generate the container plugin, or a remote would use the container plugin. And what we're going to see in here is we obviously import a couple other pieces. Most notably, we import something called a container entry dependency, container module factories, and the container exposed dependency. And then, of course, because this is the remote, we actually pull in the overridables plugin as well. And the overridable plugin is mostly responsible for offloading a piece of vendor code or anything else. So if the host overrides it, it will depend on the host's version of whatever the override is. But if the host doesn't override it or it doesn't exist, it's overridables plugin that creates that ability to kind of self-heal, where if it doesn't find the right version or doesn't find that dependency shared, the fallback is the remote will load its own version of that module or dependency. And that all happens inside of here. So let's go through here and look at what we're actually doing. So the first thing that we're going to do is I would take the overridables that get passed in through the options, and I immediately pass that into the overridables plugin and apply it to the compiler. The next step here is pretty much a hook that we're going to tap into. We're going to tap into our make hook, and what we're going to do is create a new container entry dependency. And so this is just another dependency factory or a dependency that we've made, and there's really not a whole lot going on inside of it. It just exists there so that we can really add the exposes part onto it, and also for some caching and naming conventions. But the only thing the dependency really does is gets a list of whatever we're trying to expose, and we pass it into entry dependency. If we look at entry dependency again, this is just a requirer of module dependency, and this is just the normal entry dependency. This isn't actually part of module federation, it's just part of Webpack. So that's kind of how we're extending and hooking down into it. So let's jump back into the container plugin again. And you'll see we pretty much create this dependency where we pass in whatever we're going to expose. And then we're going to go through and actually add a new entry point to the compilation. So this entry point is essentially that remote entry in all of my examples or demos. The file name gets passed in from the options, the library, all of that is pretty much coming out of whatever options you configure inside of Module Federation plugin, or inside of the container plugin if you're using it in this kind of 50-50 split way. So that's actually how the remote entry gets created, is we pretty much just add a new entry point to the compilation on the fly. Give it context, names, library, all of that. So once we create this new entry point, what we have to go in there and do is pretty much add some dependency factories to it. So the dependency factories that we would add here is the container entry dependency, and that again is going to have the exposed section attached to it. And we're going to also add this container entry module factory. And then of course we also have the other set of dependency factories, which we pretty much add the exposed dependency to it. And the exposed dependency is really creating that exposed layer. That's how we are able to expose only pieces of the app. So let us jump into our container entry module factory. Here's what the module factory looks like. So inside of here, we just extend Webpack's module factory, and inside of the create method, what we're going to do is pass in the list of dependencies that we've collected, and those dependencies should pretty much just be one dependency, I believe. And what's happening is we're now actually pulling the exposes section out of the dependency that was factorized inside of here. So that's really why we have this container entry dependency, and that's why we set exposes on here, because once we're down inside of a module factory, we can look at the dependency, and on top of that dependency, we should just be able to pull out the exposed items that are on it. So what we'll end up doing in here is inside of this create, because this is a module factory, so it's going to create modules. What we'll end up doing is firing off a callback. The callback is going to have the module on it, and then we're actually going to go and create a container entry module. And if we jump over into that, container entry module just extends the normal Webpack module, so nothing too fancy going on there. And you'll see we also import something like async dependency blocks and import runtime globals. And we also import this container exposed dependency. So now we're looking at the module. And so this is kind of the entry module, which is what gets executed as soon as Webpack lands on the page. So when Webpack runtimes are loaded, they're going to execute the entry module first. In the case of module federation, what we do is create a highly custom and specialized entry point with a customized Webpack runtime. And that's how we're able to create this interface between the two. So if we just scroll through it, you'll see we also pass in whatever gets exposed. We add some identifiers, readable ones, if it needs to build or not. And then over here inside of build, which is essentially what kind of puts everything together, what we're going to do is again call on this exposed dependency, and we're going to pass it the name and the request. So if we jump into exposed dependency, what you'll see is we get this exposed name. So what this is more or less is this is the name that you actually pass inside of Module Federation plugin. And what it ends up doing is creating this ability to have a specific part of the app exposed. In order to do that, we have to move it into its own kind of dependency, and we also label whatever it should be exposed as, or whatever it should be exposed by. So we create it up, we push this into the dependencies of the container entry module itself, and then we pretty much loop through it, and what we're going to do is pretty much shift these things into an async dependency block. And yeah, so this async dependency block works very similar to your code split. It allows us to now shift off a certain module, a certain file, and make sure that it doesn't go into the main bundle. So we don't end up downloading, say, 500 kilobytes when we're only after, a very small portion of the app. And the other thing that this does is it makes sure that the Webpack runtime remains really small. So when you embed a remote entry onto a page, you're not really embedding the actual code that goes with it. All you're doing is embedding a Webpack runtime. how we keep it from getting large is through async dependency blocks. So what you end up adding to that Webpack runtime is actually just the references to other chunks. You don't actually add the real code into the runtime. The runtime is pretty much like a manifest with a whole bunch of dependencies that are listed on it, and all of those dependencies are pretty much code split out. And when you decide to call a dependency, a promise fires off and returns a little factory function. When the factory function's executed, it returns the module underneath it. And that's how we keep everything really small. So that's the build aspect of this. Now, there's also a code generation aspect, and code generation is a new API of Webpack. And what this actually takes over the responsibility of is creating the strings or the code that actually gets written to a file. Pretty much what happens is we specify some runtime requirements that we're going to need. And this just tells Webpack what it should add to a Webpack runtime. If you aren't using certain aspects, it's not going to actually add it to the runtime. In this case, we are using, certain basic aspects, so we need to make sure that those are listed as runtime requirements. Then what we're going to do is pretty much loop over the blocks, and we're going to get the dependency off of it. We're going to get the exposed name of that dependency, and what we're going to do is look up the dependency inside of the module graph, and we're going to grab the original require statement or the request of it and just store it here. It's going to return a little template that we've got, which creates a promise, and inside of that promise we're going to pass some various aspects. We then go into the then of the promise once it's resolved, and we add another function that returns stuff. Inside of there we have another function that returns stuff, and this pretty much keeps things from being executed too eagerly. And the final thing that we actually are going to return is a module raw. So what a module raw is more or less the ES module or whatever module that you've got. So we give it the module that we've created, we pass the chunk graph back into it, and we pass the request. So import, source / whatever. Is it weak or not? In this case, it's always set to false. And then we pass the runtime requirements that this module has. And again, this is all really around creating the Webpack runtime entry module. That's why we have all these runtime requirements and these async dependency blocks and all of this stuff. So then we can go down here and we'll actually see the source. So this is where we actually write code back into the Webpack runtime. And what we're actually writing here is we create a little module map. We have a bunch of getters that we pretty much join together, and these getters are stated over here. And we create a little basic function. It takes an argument of module, and the body of that function is that it's going to return a runtime global property with a module map and a module, and then we just have some conditional logic in there. If the module map exists, if the module is there, execute it. Otherwise, resolve a promise and throw an error saying that the module can't be found. And then we go down here, we have the override part. Basic function again takes one argument, and we object assign runtime global overrides to this override property that gets passed in. And the last thing that we do is we create a property getter with the exports on it, and this is just something Webpack has. And then inside of there, the kind of default property getter that we're going to have is pretty much a little function that exposes get and override. And that's how we are able to retrieve stuff or override things from a remote. So let's have a look at what actually gets generated when we do this. And you'll see what this file is responsible for actually creating. Alright, so here's like one of our examples. I'm going to pull up the inspector here, reload the page, and I want to see what this remote entry looks like. And this is how we can kind of compare the code that I'm talking about and what container entry module does to the code that we actually see inside of this remote entry file. And over here is where you're pretty much going to see this module map that I was talking about. You'll see get, you'll see override, and you'll see this exports with a get and override, and kind of how we're extending it. And so this is essentially the module that gets bootstrapped when the remote entry starts. And what we can do is just come back over here, and you'll see more or less module map. We go through, create some getters, we have functions on here and whatever, and you'll see some kind of correlation there. In this case, I exposed dialog, and this is what it ends up returning, which is pretty much this promise all. It uses lower level Webpack stuff to go in and get whatever dependencies are required, and then finally it resolves to requiring the dialog. So this is how I'm able to go ahead and get chunks that are split out. And that's really what the async dependency block is doing, is it ensures that this is not the actual Webpack module. It doesn't have the 8, 10, 20, 50, 100 kilobyte. All it has is a reference to another module that is somewhere else. So just like how code splits work, we have the same mechanics being implemented inside of here. When you're using this inside of your app, regardless of how you import it, you don't need to worry about the whole code split aspect of, well, if it's in an async dependency block now, does that mean I have to dynamically import it? No. Inside of the host or wherever dialog actually exists, it could still be required using a normal synchronous require statement. And yeah, so that's kind of what's going on in here inside of this module map. And then down here, you'll also see where we kind of create some overridables, and that's again another part of this whole plugin mechanics that get generated. So that should take us through container entry module, and that is, that's what's creating the piece that gets bootstrapped here. And yeah, this is the module that starts itself off. We have container entry listed right there, Webpack module, we pull this in, and this is what kickstarts exposing code to the end user or exposing code to another host. So yeah, that kind of wraps up what container plugin does. What we can do now is actually dive into the override section of this, and overrides Tobias wrote, so it's a little bit complicated, but I'm going to try my best to explain more or less what's going on underneath it. So inside of Overridables plugin, we obviously import a whole bunch of things. And you'll see we also have a overridable module, override original dependency, overridable original module factory, and overridables runtime module. So it only cares about the overridables part. And what we end up doing is inside of the current compilation, we're going to tap into some hooks. We create another set of dependency factories. And in this case, what we're doing is we're going to have the overridable original dependency and the override original module factory. So I'm going to look at the dependency first. The dependency expects a original module to be added to it. And what we do is forward the original module's identifier into it. When we serialize it, we serialize the original module, and we do the same thing when we're deserializing it. And all of this is really part of the caching mechanism that's built into Webpack. Similar to how we did the exposes part, overridable original dependency is responsible for attaching some piece of metadata that gets used later on in the factorization of dependencies or modules. In this case, I want to know the original module that I'm going to override. And this is kind of what we would pass in, say, if this was React, or if this was, Lodash or Moment or something like that. That's what we're passing in here, that original module. Not just the request, but the actual Webpack module that would have been created. And what I'll do is go over here and we can look at the actual factory that consumes this stuff. Inside of here, we have our dependency. Pretty much, we go off of data dependencies and we grab the first dependency off of it. And the callback in this case is the original module that we would create. And that's kind of how we set up this dependency factory for it. So then what we've got is obviously a little bit of context here. And what we end up with over here is this big promise all statement. And so what we're doing inside of here is we go through the overridables. We have the key and a request off of it. And what we're going to end up doing is resolving it with the resolver factory, and we're just going to resolve the normal modules because that's what they'll end up being anyway. It's going to return a promise, and this is pretty much going to be called once the resolution of the file or whatever is done. And what we'll end up doing is down in here, resolved overridables, and we pretty much set the result in the key of whatever overridable dependency we're actually going to end up resolving this to. Once we're done resolving all of the potential shared or overrides, the next step is going to be we add context dependencies, we add the file dependencies, and we add any missing dependencies that would end up being thrown. After we've resolved everything, we really just call this callback. Inside of Hook's module, what we'll end up doing inside of here is we have our resolved overridables, and what we do is we end up getting that resource. If the resource exists, we create the actual overridable module. So we pass in the original module that we want, and we pass in a key. And the key isn't like 1, 2, 3, 4. The key is more like React or React v16.4 or whatever you're calling it inside of shared when you pass an object. So if I look at the overridable module, again, you'll see this async dependency block. And what it pretty much does is inside of the constructor, we set up some metadata about it, some way to identify it. And then inside of the build step, what we're going to do is create a pretty much empty async dependency block. Then we'll create a dependency, and what we do is similar to how exposes work, where we take these files inside of source or these other things that you're trying to expose and we split them off into their own standalone file. The same concept is being applied here, where I'm going to create an empty async dependency block, and then I'm going to take, say, React or Lodash or Moment or whatever it is. I'm going to take that original module, and I'm pretty much going to move it in the dependency graph out of wherever it is, so whenever you require, say, React or something, you're not actually requiring React, but you're requiring the overridable module, which is this. And what overridable module does is it will have a async dependency block on it, just like a code split would, and that's what ends up taking the original file that you had, pulling it out, injecting it somewhere else into Webpack's graph, and creating a dependency on this overridable module. Now, if I go and import React and React is shared, you're going to hit this. It's going to have this code split block. So in the case where it doesn't actually have React shared from the host, the overridable module knows how to go and find the reference to the original dependency. And that's how we go and actually download the real copy of React back from the remote origin, assuming it can't be overridden. We go to the block, add a dependency to it, and the dependency is, React, Lodash, whatever you had. And how it ends up getting created is as a async dependency block. So we're pretty much adding specific vendors that are going to be treated as promises or as code splits. Update the cached module. Pretty much we're going to go in here and we're going to now change where this cached module comes from. And we'll update the hash of it. So then we're going to actually get into the code generations. And this is where, again, we're going to write the code that you end up seeing in the file. This is what actually gets emitted inside of any Webpack module or any piece of JavaScript is whatever you put inside of code generation. So in here, what we've got is pretty much raw source. And again, we're going to pass the original module in. We're going to pass in the chunk graph, runtime requirements, a couple other things. What this part is really just the module piece. So inside of the runtime, you're not going to see it be a direct part, but this module here is really this. So if I go and look for something like the overridable section, let's say this is React. So that's what I created it in as shared, or, I can also do it as a versioned code as I'm doing here. And this is the actual module that ends up getting created. So you'll see it's called Fallback Mapping, and this is what we actually are manufacturing here. So this is what this overridable module ends up looking like, is this. And that's how any of the shared things that you would usually put in, this is how it's actually able to be overridden, and also how you're able to fall back onto the original version that's inside of your source build that the remote came from. It's through this kind of mechanism where we take your original request, we shift it and move it into a async dependency block, and we only call it if we need to. And this again comes down to another part in the Webpack plugin where we actually have overridables and we go through and list, is it there? If it's not there, go and get it. And that really is part of this overridables part. And if we dive into it a little deeper, you'll see we have a chunk mapping, the chunk ID, and all of this is really to check, does it exist yet? If it doesn't exist, then you need to go and resolve it and pull it in. So this really is just the overrides fallback section. If we look for the actual overrides, that is kind of an empty function, or that's kind of like an empty object, and the host is writing the overrides into a remote. So it's going to check if the host has written them. If it hasn't written them, it's going to fall back, go and find the chunk that it needs, go through all the mappings that we have here, and you're going to end up executing what's essentially a dynamic import. That is a promise anyway. And that's how overridables is able to work. So let's go back and look at the overridables plugin now that we've seen what the module factory looks like. So we have the runtime requirements. And again, inside of here, we are adding a series of things that we need. We're going to also add a new runtime module, and that's the overridables runtime module, which is this. And that's how we're adding stuff to the Webpack runtime, is through this kind of mechanics. And then we've got a parser on here, and what we're going to do is pretty much add a new type of parser capability to Webpack. And that parser is going to have some kind of const dependency that gets generated. And if we go and look for Webpack override, I don't know if we actually find it in here, because it probably ends up getting transformed. So that's the core of overridables. If we want to look at, say, the overridables runtime, we're going to see a generate section on here. And you'll see that this is where we take all of those modules that we've created an overridable module. This is how we actually loop over them and attach them to the page along with everything else. Looking through it really quickly, you'll see we get the ID out of the chunk graph. We push it into overridables. We get the source code that was generated. And we're going to go through here and you'll see, there we go, there's the chunk mapping, the name mapping, and this really takes care of if I don't have the overridable available from the host, what chunk does it exist in? Okay, now that I know what chunk it exists in, the Webpack runtime can go download that chunk, just like you would do with code splitting or anything else. It gets the chunk and then calls the module once the chunk is there. So we have the same kind of mechanism happening here. We're just creating a couple additional maps so that the runtime knows what it's doing. And then down in here, this is actually where we create the overridables method. And on there, it'll expect a chunk ID and a series of promises. It then checks if it exists or not. And again, this is where you start to see us perform the same kind of code that you're seeing over here. And that should more or less cover overridables. So if I go back to Module Federation plugin, everything that we've gone through is pretty much container plugin right now. I might have missed one or two things, but that's pretty much what we've gone through. I've just covered the remote. What happens on a remote when you do exposes? What happens on a remote when you use shared? The next part of this is we need to think about the consumer aspect. So what happens when a app is running in host mode? Or what happens when you just have a host and it wants, and what happens when it wants to import some piece of remote code? So inside of the container reference plugin, what we'll end up seeing is a series of, again, modules, overrides, dependencies, all of this stuff. The one interesting call out here is there's been a lot of feedback around module federation, and some developers haven't really gotten it and just said, oh, well, this just looks like, externals. And in reality, here's externals. There we go. So it's one line inside of all of this. There we go. So yeah, sure, we leverage externals plugin, but it's a line of code, and it is responsible for doing literally like one module. If I go and look inside of here, I don't know if I'm gonna see it inside of this runtime, but it really just exports out. Externals is responsible for this block, literally that file. That's all externals does inside of this whole thing. It is one line of code. So getting back to it, the container reference plugin is going to expect you to have the remote type defined. It's going to want a list of remotes, app 1, app 2, app 3. You'll see like over here, app 3 from container reference. And the overrides. So what is the host going to intend on overriding inside of the remote? And now this is the other half of the module federation mechanics. So inside of the apply, I create a new externals plugin, and all I really do is attach the remote type for it and the remote externals, which is really in this case just the key that we're going to pop off of your remotes. So app 1, app 2, app 3, that's all that we do. App 3 or whatever, just like that. So that's what this does. It doesn't do anything else but add that. So now we get into some of the hooks that we're going to tap into. And the first thing we're going to do is set up a bunch of dependency factories. Inside of the first set that we've got, we're going to have remote to external dependency. And it's going to create a normal module factory, or it's going to use a normal module factory. And if I go over here and look at remote to external dependency, all we do is pass the request along, and the request goes into a module dependency. And this is just vanilla Webpack again. We don't really do anything fancy here other than give it a type. So inside of debugging or infrastructure logging, we can see what's going on. And we also add it to Webpack's internal cache system. In our next dependency factory, we're going to define remote override dependency. And if I look at that, again, module dependency, it's really just setting up some basics. We don't even add anything onto it. We're just forwarding along the defaults. And it's mostly used for logging and caching again. And then the last one that we've got is going to be remote to override dependency. And then inside of here, this is the one where we actually are passing in the overrides. So the host is willing to override React or whatever else. And so for that, we have our caching mechanism set here to read and write from cache. And inside of this module dependency, just like we did with exposes and just like we did with overridables, we're going to set some additional property or metadata onto the dependency itself. And in this case, it's what it's willing to override. And the reason that we do that is so inside of here, when I'm actually in the remote override module factory, I can do something that's very similar to what we've seen before. I'm going to go in here, and the callback, there's a module for it. The module I'm actually going to end up returning is a remote override module. It's going to take in a request, and it's going to have the dependency overrides listed. And if I go and look at a remote override module, we're going to have the request and the overrides that are listed for it. And now this is where things are a little interesting. Inside of the build, we add it as a dependency. And what we're going to add as a dependency is pretty much remote to external dependency with the request. And again, that doesn't have a whole lot in it. And again, we're going to go through here, create these async blocks, add this code as async so it's available. And then inside of the code generation, this looks really similar to some of the other ones we've seen, but in this case, what I end up doing is I'm going to go and require that external module ID. So in this case, let's say I have app3 from container reference. I'm going to get app3, and what I'm going to do on there is I'm going to tap that override method. So if I look for override, it's here. So this code would pretty much be doing something like this. Require, and then it would be app2 dot override it. And what we're going to end up passing in is a big object. And so that's how we're actually able to get into this whole system. So in the case here where we actually literally go and require the external module, what we would end up with is something more or less like this. app2.override. That's how this all comes together. So now that I have my external, I override it, and now what I'm able to do is create a whole promise setup again and go through and actually determine what it is that I'm going to be overriding. And the remote override module is also used inside of the actual require that you make. So you'll see inside of the runtime, I don't have something like override, just like that. I have override listed here. And here's an example of it right there. External, require, container reference, app3, the external, and we're going to go in and pretty much override these properties. And so that's how overrides is working, more or less. We generate the original source of it, and we spit out the sources and any runtime requirements that are attached. So if we go all the way back to the container reference plugin, you'll see here we're pretty much doing similar to what we've done in other places in the app. We're adding some piece to the runtime. We're creating overrides in this case. We create the external module so that it knows how to reference it, or so that the host would know how to reference it. And then when it's executed, what we end up doing is we attach the overrides onto it. And what we'll end up actually resolving it with is just we export back out the external that was already there. So we get it in, we override it, and then we export it back out. And so that's kind of how you end up with that capability to go require app2 / whatever, and you get whatever you want. When you're doing that require app2 / whatever, what you end up actually requiring is more or less this thing. So as you're getting your module that you want, we attach the overrides onto it and ensure that app3, app2, whichever app it is, like in this case, is overridden before we return it. So that way, before you even execute anything from app3's runtime, we've already stated the overrides. So when you actually run the requirement that you want, it's going to see it already has these things, and it won't load those fallback modules inside of its fallback mapping. So then we get into something here that's a factorized hook. And this is where we're able to tie things together. How do I know that, like you've seen in examples, I've got, app2 or whatever. But how do I actually know where app2 is? And how do I know where thing or whatever you're trying to import starts and finishes? And how that all gets parsed and processed is inside of the Factorize section here. We look at the request that's coming in. So this is what we call a request, or if this was a require, same difference. Oh gosh. The same kind of concept applies. The request is whatever you're requiring. So when we go down here and look at it, I'm going to go data, request includes, and pretty much make sure that this isn't some kind of a loader-based function or a loader query. If it's not a loader query, what I end up doing is I go through all the remotes that you would have listed, app2, app3, app1, whatever it is. And if the request that's currently being processed starts with anything listed in the remotes, aka it starts with like app2, we then process this differently. Otherwise, we skip processing it entirely, because it's just a normal Webpack module. Webpack will handle it. Yeah. So if it starts with, say, app2 in this case, then what we're going to end up doing is returning a new remote module. And this is how requiring something like this that doesn't actually exist in your current bundle doesn't break your build, because we do actually resolve it with some code. And the code in this case is what we call a remote module. The remote module takes the original request that comes in. It's going to take a list of overrides that have already been put together up here. It's going to have some kind of a reference key for it. And then what we're going to end up doing is pretty much actually passing in this section, or everything that's past the key. So what I'll end up doing is the remote module doesn't get app2/thing. The remote module gets just that part. It doesn't get the whole, the whole thing. And that's how we're able to know, okay, cool, this is app2, and I'm going to do something on app2, which in the case of this would be, cool, I have something called container reference/app2, and then the actual request that I'm going to make internally, what I want to get from app2 is whatever is past the slash, app2/ or whatever your real request is. That's what gets mapped into remote module, and that's what remote module ends up looking for. So we're just going to jump into the remote module, and you can have a look at it. So we've got the request, we have the overrides, we have the external request and the internal request. So the internal request looks different, app2/whatever. The external request would just be /whatever, more or less. Inside of the build of this module, what we'll end up doing is we clear any dependencies out. And then we're going to check, okay, are there any overrides? If there are, we're going to add the dependency to remote module. And the dependency that we add is remote to override dependency. And that's where we get our whole mapping for the external request and for our overrides. Again, going into a module dependency, which has its own module, and we go off down this whole chain again. And yeah, so remote module will add a dependency to it, and that dependency is pretty much the actual thing that you want over on the other side. If there are no overrides listed, then it's just going to run the external request. However, if you do have overrides from your host, the shared section, if you have shared on your host, what we'll end up doing is passing in the remote to override dependency, where we get the external request, we get the overrides, and we push them down into the app. So what ends up getting returned is a little code block similar to this with overrides. And that's pretty much what this one does right there. So I have this lookup that I'm going to use, and when you require app2/thing or app2/whatever, you're actually getting this from your host build. This is what gets exported out, is this segment here. In between it, we override stuff, and that's how we make sure that app3 doesn't try to download any of these vendor dependencies or any of these shared modules from its own build. That all happens in there. If there are no overrides listed, then we just use a slightly different variation where we don't have to include the various override pieces to it and all of the kind of boilerplate that comes with it. So if you're not having overrides listed in your host, you would not have any of the code highlighted here. You would just export it back out. That's what ends up getting returned. Whenever you import something in an app, if we go and look at a practical example here, so there we go. That's going to return remote module, which is this file. And inside of there, it's going to just have a dependency attached to it. And that's really all that we do. That's how we connect everything together. The module has a dependency, that dependency gets attached, and when we actually try and run that require statement, it has what it needs already available. And then at the bottom here, we've got a requirement tree. We tap into Overridables plugin, and we pretty much just set pieces that we need. And the last kind of part on there is we're going to add a new runtime module to it in this case, and that is going to be the remote runtime module. And if we look at the remote runtime module, it's very similar to where we've kind of gone with this already. We've got our chunk mapping, and just like we had with the vendor code, we've got the same kind of thing here. There's button, so when I import button, it can do the cross lookups inside of itself of it. So I require whatever the first half of the request is, and then I get the second half of the request. So that's how a require statement like this ends up actually running through this mechanism right here that gets added. So what that actually comes out to be inside of a browser example would be data 0, which is in this case is app2. And then the get part of it here, data 1, is pretty much, that's where we're splitting this thing. So I split this part, move it over here, that's the scope, and then the original external request is button. And that's kind of what Webpack's doing in the browser version of this. This is going to return a promise, and you'll see inside of here we have, this whole factory aspect that gets attached. So what that ends up looking like is our factory there. And there we are. And now we've got our module listed, and then you could just return the module if you wanted, or the proper way that it happens inside of Webpack here is we attach it to the module exports. So when this whole thing gets executed, you'll notice that module ID equals a function that then exports out the factory. And that's how we're able to prevent this from running too soon and only running when we want, because only once this is called and we actually go through our remotes and start executing them, when you require it, it's going to run, attach the Webpack module ID, which is going to equal whatever module gets passed in. This is just kind of normal Webpack, how things work. Because it's already a promise, we can just attach the exports to it, which would already be resolved when this piece of module code is loaded. So you end up getting an export that just contains, this module. That's how it gets exported out. And that's how something like, app2 button is able to run inside of the host, is through this whole mechanics. And it's very similar to how overridables work, the same kind of mechanics there that we attach. So it's all working very similarly. It's just really how we look for things, how it gets overridden, and how we're able to split code apart from other things, and really how we look it up. And that is more or less the whole Webpack module federation plugin. If you wanted to do something like do this manually, I know there's been questions around, well, how would you do this in a fully dynamic scenario? So where I don't list remotes or anything like that. If you're looking at the runtime here, you'll see that you could instrument this without Webpack's knowledge. It's just ugly. So we can look at what it would look like if you wanted to, say, dynamically define remotes or hosts or overrides or anything like that. In this case, I've actually created a Webpack 4 backport. So here we go. In this case, I have something called A/B tests, and I've got an override. So somewhere inside of your host, you would have window, scope, override, object to sign in, React, React DOM, anything else that I want. And then in this case, I'm trying to dynamically expose the whole components folder. So what I would do is very similar to what we kind of have written in the Webpack plugins themselves. What I'm pretty much doing inside of here is actually creating a custom mapping system. Because I'm doing this for Webpack 4, I have to go through and use like the require context and kind of load what I want in. And then to actually get it to work inside of Webpack 4, I literally have a export that's literally pieces of runtime from Webpack 5 to perform this. But what you would really only need is somewhere inside of another app to dynamically set what can be shared. You would have something that looks like this. However you want to generate it is your call. And then how you would consume it would be something kind of like that. And that's how you would be able to, and you know, dynamic is a Next.js thing, so you don't really need it, but you wouldn't have to recompile the host app or the main app if you added a new remote or anything like that. You really just lose out on that advantage of having this kind of sugar syntax that we've created where you can just use import abtest/webpack4 federation. But if you needed to achieve the same kind of capabilities, these are the mechanics that you would use. You would pretty much be tapping into like the lower level aspect of this and executing some of what the Webpack runtime is already doing, assuming that it knows about the shared or about the remotes that a certain host is consuming. So yeah, that's pretty much what it would look like. And you know, what this all actually kind of boils down into is we more or less recreated a manual version of remote module. We've got our override that we attach to it, and then we've got the scope that we're going to send out of it. We're just not exporting it out in this scenario. We're consuming this directly, but the same kind of principle would apply. And yeah, so I know that was a bit dense possibly, and I might have gotten one or two things incorrect, so I would recommend just going through and looking at it yourself if you want to understand it better. And if you do actually want to see how the implementations or something like that would look, the easiest way is to look at tests. If you want documentation or something like that, the best case scenario is going to be tests. So you know, there's examples for how this would look, say, in a common JS scenario. And then the test cases really let you see how you would call stuff or how it would look. So it's really handy to just go through and look at the test scenarios. Container.override, you know, non-webpack require, you find the remote entry or whatever, or if it's on the window, it's just, you know, window, whatever you called it. And that's how we kind of recreate it. So if you want to look at how to do some of these things more dynamically, I would definitely recommend just digging around inside of our test cases here, and you can see how we actually create these override systems, how Webpack override works, how all of these things get performed. So that kind of covers everything. I'm not going to dive too much deeper into all of this. If you have questions, you can find me on Twitter, Scripted Alchemy. Pull it down, give it a try.